Hello. In this video we are going to look at an introduction to an idea called resistance. Now if I draw a very simple circuit, I'm going to write resistance at the top. I'll draw a simple circuit. I'm going to take a battery and a bulb. Now you should draw the wires with a ruler, but I'm keeping it neat, so I've got an excuse. Also, it takes too long on the video. So, what resistance is an opposition to what we call current. Now, current is the movement of charges around a circuit. Okay, and charges come out of the battery, they go through components, they go back in the other side. So the battery is the driver of our circuit, and the current is what carries that. And current comes out of the battery and goes back in, but when it comes back in, it's got less energy than when it left, but the same amount of it goes past. It's like a car driving along. As it drives along, it uses up fuel. It's got less fuel at the end, so something gets used up along the way. But that's not represented by the current. That's represented by the car leaving and arriving. You just don't see the fuel tank. It's a bit more empty. And in this case, when it gets to the end, it's empty. Now, what resistance is an opposition to that. So this circuit has 1 bulb's worth of resistance. If I then draw another circuit with 2 bulbs, in one of my previous videos we talked about how having 2 bulbs reduces the current. In fact, it halves it because there's twice as much in the way. But the technical way of explaining that is through this idea of resistance. And what it says is, well, with 1 bulb it's X difficult to get past, but with 2 bulbs it's twice as difficult for the current to get through. So what that means is it halves. It's twice as difficult, it halves. Now there's a component called a resistor, and the circuit diagram for that looks like this, just a box or rectangle. So what I can do is represent these circuits or redraw them, but just with resistors. And what I'm going to do, I'm actually going to draw a line here to say, whilst the structure may be the same, they are different circuits here. There's a few circuit faux pas, like just not quite lined up, but it's just doing it quickly for the video. Now, this circuit here, you've got 2 resistors here. Now, if we said you have a current here, if you drew the same circuit or a similar circuit, but you only had 1 resistor. Now what's important here is that has a resistance of R, that has a resistance of R, that has a resistance of R. What would be the current in this circuit compared to that one? Because they're series circuits, it's the same current everywhere. And hopefully you've identified that if you halve the number of resistors, you halve how difficult it is for the current to get through, which means the current doubles. So if you had a current of 0.2 amps here, you've now got a current of 0.4 amps. And if you put a lot of resistors in, 1, 2, 3, 4, but all with the same resistance of R. I know I've drawn them physically smaller, but that doesn't matter. I've labelled them and they've got the same resistance R. There's double the number of resistors compared to that circuit, which means it's twice as difficult compared to this circuit, 4 times as difficult as this circuit, which means the current is 0.1 amps. So if you double the number of resistors, you halve the current. If you halve the number of resistors, you double the current.